Hello, science lover. This is Sai Portrait, a podcast where we explain science puzzles in a way everybody understands. This podcast is brought to you by STEM The goal of STEM is to make learning fun and interesting for kids. The games and exercise on STEM are fun and help kids learn with math and science at the same time. I'm your host, Dr. Bishrit Poddar, a scientist with more than 12 years of research experience in cancer disease. Today, we are joined by Christian Mavris. He is an Italian Greek geologist and journalist. He has a strong passion for science communication and a rich background in geology research. He completed his graduation in Italy and he earned his PhD at the University of Zurich in Switzerland. He has worked on postdoctoral projects on diverse applications of mineral alteration from the Alps and the Rocky Mountains to Mars and honeybees. One fun fact about Christian, he is a passionate mineral collector. In this episode, we learn from Chris about the rock to minerals, art to Mars, and environment to honeybees. Without further ado, let's start. Hi Chris, how are you?
Thanks for having me. And hello to you and our fellow listeners.
It is my pleasure that you made time to come in my podcast. Can you tell about yourselves for our listeners?
Sure thing. I am a 40 years old geologist and journalist, as you very well underlined. And I want to underline that my path between academia and communication hasn't always been like a straight line. I always liked communication while I was doing academia. So I was always more keen to join conferences rather than to stick to the lab. But at the same time, I accomplished also some good research work. And I like the fact that most of the projects that I have followed were driven basically by passion, as you might notice eventually during our podcast. One thing I would like to underline also for our fellow listeners is that honestly, so I thank you for the opportunity, Bishop.
You're welcome. Thank you so much for joining. You are a geologist. We were going to talk about the rock, minerals, and all those things, right? So probably many of my listeners are interested to know what actually the rock.
You're most likely referring to this.
Of course, yes.
In a most general definition, I would say that rock is a solid admixture of various chemical elements stable at specific environmental conditions. Now, rocks can be of three types. Sedimentary, which means deriving from previously dismantled rocks. Igneous, deriving from molten rocks. And metamorphic, deriving from buried and or heated pre-existing rocks.
I see.
Now, rocks can be distinguished with numerous methods, as they typically have a plethora of distinctive features such as texture and specific minerals, which become key to understand the conditions that led to their formation. But the first approach is rather basic: observe and touch.
Right. So then I want to lead another questions. So could you start by explaining what minerals are and why they are so important to our plants' ecosystems? We know what is minerals and all those things, but we don't know the impact of the minerals in the environment, in the earth, in our ecosystems. Can you explain a bit more?
Sure thing.
Yeah.
So while rocks are composed of one or typically more minerals per se are solid compounds with a very specific chemical formula and crystal structure, which is basically a repeating pattern of the arrangement of the atoms dominated by well-defined symmetry.
Right.
Now, both things compose the fingerprint of a mineral.
What is like fingerprints? So you mentioned about...
Basically, they have a very specific chemical formula.
Continue.
While rocks are composed of one or typically more minerals, minerals are solid compounds with a very specific chemical formula and crystal structure, which is a repeating pattern of the arrangement of the atoms dominated by well-defined symmetry. Both things together, chemical formula and crystal structure, compose the fingerprint of a mineral. Minerals now are incredibly important natural compounds for lots of reasons. Think of the building industry, for example, where limestones are important for concrete, or iron ore is for cars, or rare earth element bearing minerals are essential for the extraction of elements key for new tech cars, or diamonds, important for both jewelry and high-performance abrasives. Left alone, how mineral structures and chemistry often become the templates for new compounds and materials. These are just a handful of uses that cross my mind, Bishop. But there are so many others.
Right.
Minerals are all around us, and as rock formers, they literally represent the very ground we step upon. Now,
Hmm.
when it comes to the planet's ecosystem that you asked, their role is essential.
Right.
Minerals represent a pool of nutrients for living organisms. How is that? Well,
Yeah.
for example, microbes and roots feed on minerals by extracting these elements from the crystal structure. It's like their meal, and it's a pretty basic mechanism at the bottom of the food chain. One
I
could
see.
say that a simple organism requires a simple meal, that sort of thing.
Okay, cool. So you're telling about that minerals could be kind of meal for some species in our ecosystems,
That's
is
right.
it? Okay. So you are explaining about like what is rock, what is minerals. So how do you differ in between rocks and minerals? Why is this distinction important for understanding the process for making art? Can you explain on it?
I think that more than a distinction between the two, so minerals
Hmm.
and rocks, it is essential to understand that a rock can contain one or more minerals, whereas minerals are the bricks to build rocks. It is
Okay.
just a one-step difference in the grand scheme of Earth processes, really. It's
Hmm.
like a Lego house is composed of small bricks, for instance.
Right.
Brick size and features vary, but we're still dealing with a construction game, and the brand remains the same.
I see. So, is there any like bad minerals or good minerals if you talk about it?
You mean like in the means of, for example, being toxic?
Yes.
Well, it all depends on the purpose of the
Okay.
mineral and or the use of this mineral. You can have arsenic minerals, for example, that are some of the prettiest minerals in the world. They are very much
Right.
loved by mineral collectors. They are called arsenates.
Yeah.
And at the same time, because they contain arsenic, I wouldn't necessarily eat them. Let's put
Okay.
it this way. Or
Right.
you can have uranium minerals that are incredibly useful for a range of uses. Back in the days, they were used, for example, for paintings. And
Mm.
nowadays, you can have like either paintings or you can have like specific pottery or specific glass that is still radioactive. So, pretty on one side, so
Hmm.
very useful too. And on the other side, toxic or eventually even harming.
Right. Okay. Cool. Thank you. So, is there any trends to break the minerals, or is there any factors involved how they are broken down? So, can you go that
Well,
direction? Yeah.
absolutely. So chemical elements, as we know, are bound together to form a specific crystal structure. Okay.
Hmm.
Now, their stability of those crystal structures and the mineral per se, depends on the environment where they are in a specific given moment. So when the surrounding conditions are no good for the stability of the mineral, the latter undergoes a change, which is called alteration.
Right.
So when it comes to processes, there are plenty: water, wind, direct sunlight, but also activity by plants and all sorts of life forms, especially the smaller ones, such as microbes or
Yeah.
microroots. Some minerals are more resistant than others. For example, take quartz, also known as silica oxide, the one that makes glass-like crystals such as
Yeah.
amethyst, the purple
Hmm.
one that we know, right?
Yeah.
Lots of people have amethyst as decorational stones.
Yeah.
Now, this species is usually very resistant, even in a very acidic environment.
Hmm.
Some of you could even wash in the dishwasher eventually at steam hot temperature and nothing would happen to it.
Yeah.
Now, if you go to the beach, where one quite often walks on the beach, eventually one ends up walking on a quartz rich sand.
Yeah.
Now, this quartz there that is totally ground occurs because the waves have significantly abraded the quartz rich rocks, breaking down the quartz crystals.
Hmm.
This is not a chemical, it's rather a mechanical abrasion, which grinds the rocks, and in the case, the notorious resistant quartz too. So basically,
Right.
that's where we have mechanics that overcome chemistry. On the
Right.
other hand,
Hmm.
let's think of another compound that we know, kitchen salt, which is a household plain
Yeah.
compound, right?
Yeah.
It takes just a bit of humidity to break down the structure and dissolve the salt, say in a
Mm.
pot of water while preparing some pasta, to the point where it completely dissolves. And on that very salty matter, if you want, I have
Hmm.
always found funny that while elemental sodium can explode, and chlorine is a
Mm.
toxic gas,
Yeah.
sodium chloride, which
Yeah.
is the chemical name for kitchen salt, is used
Yeah.
for seasoning. In a way, that's a kind of a philosophical twist of what happens in nature. An element becoming a structural feature in a mineral becomes a nutrient for a plant. And frankly,
Okay.
my nerdy side finds this.
So you can tell that minerals everywhere, even in the kitchen, like a sodium chloride that we use in as a cooking salt, right?
That's right. Even ice. For example, when you have snow and you observe a snowflake, technically, this crystal is water that is crystallized, and it even has a symmetry.
Wow, I didn't know it. The fact. Thank you for explaining about the process, how minerals is broken down. So
Sure.
now we will need to discuss about. I know that like the minerals is important, rocks are important for weathering and climate changes. So we will touch on that direction a bit now. You mentioned earlier that like when informally we are talking about that weathering plays a crucial role in releasing chemical elements into environmental. Uh, I'm right?
That's right, yes.
Yeah, okay. Can you elaborate how this process works actually in the environment?
I will try to run an example for you and our fellow listeners. I will do my best.
Okay, thank you.
Let's imagine that there is a building, okay, where you have different floors kept together by pillars and walls, okay?
Hmm. Yeah,
Now, say there is a major flood which starts taking away some walls and pillars.
yeah.
Progressively, the
Hmm.
structure will become weaker and poorer. Eventually, those floors will even collapse, get compacted until they crumble and completely disappear.
Right.
On the other hand, the pillars and walls that have been progressively removed, they will end up someplace else. This is what happens with weathering. The
Hmm.
depleted crystal structure on one side and
Yeah.
the leach elements, such as pillars and walls, are elements that break their bonds with the main crystal structure and get carried away, quite often becoming nutrients for life. This
Mm.
is just an example of how things work.
Okay, cool. Thank you. And how does climate change affect the rate and extent of weathering in glacial areas and then other environments?
That was my PhD topic, actually. So
Oh,
I spent 4 years on that
at-
exactly. So I can tell you a few things about it.
yeah.
So when we experience the increase of global temperatures, especially in traditionally cold regions and glaciated areas where
Yeah.
permafrost and glaciers still exist, ice is flowing at a very quick rate.
Hmm.
Consequently, this means two things. First, all rocks and sediments, once located underneath the ice, are now exposed to open air and will
Yeah.
progressively alter and lose mineral elements, as we said before. At the
Hmm.
same time, those mineral elements will become bioavailable and become nutrients for life. Now, usually, water is an excellent mean for transport of chemicals, and as a general
Mm.
rule, the more the available water, the higher the leaching. But obviously, it varies from case to case, as environments might vary significantly. Now, we
Hmm.
got mechanical weathering as another type of weathering, as we mentioned before, for example, and it often works alongside chemical weathering, so they can work together. Plus, bacteria, so the bioalteration, plays a significant role in the process.
Right.
Trust me, the whole field is truly vast.
Yeah. So you mentioned two terms. It's called chemical weathering and mechanical weathering. Can you explain what is mechanical weathering and chemical weathering, please?
Sure thing. The
Yeah.
chemical weathering is when you have the chemistry that plays the major role. So you have like a replacement of some elements, or you have like
Mm.
the leaching of those elements that go away from the structure and they end up as a food pool, so to speak, for the biological life forms.
Right.
And you can have basically some alteration that starts with a structure A that is pretty
Mm.
rich in some chemicals and ends up
Yeah.
with like a rather impurish structure, which eventually breaks down and might end up like collapsing and dissolving completely, depending
Yeah.
on the crystal structure and the conditions. As for mechanical weathering, this basically
Hmm.
is like the word is suggesting it. It's like it's a mechanical thing. It's like when you have like some rocks that are like rolling on one another and they're like
Hmm.
grinding. So basically, it's based on friction and hits. And
Yeah.
depending on how hard they are, those rocks, and how hard the hits are coming, you can have also some grinding. A good example, why do you have underneath the glaciers many times some little drumlins or little hills made out of gravel, for example, or like of little
Yeah.
pebbles? This comes because the glacier, it's not steady, it's active. it's grinding the underlying rock, and
Yeah.
this means that it's abrading it, so it's creating some friction and it's dragging those rocks like someplace else, and mechanical alteration.
Okay. Thank you for explaining. If you are mentioning about weathering, is there any potential benefits or drawbacks due to glacial retreat
Now, when it comes to the benefits, I would say that the lion's share is the release of nutrients. With the exposure of
in the
sediments,
environment? The release
yes,
of okay.
nutrients, the release of nutrients. So
Hmm.
when you have the release of nutrients, is basically the chemical weathering we mentioned before.
Right.
So with the exposure of sediments, it has been observed that soil forms within a time span of just approximately 50 years already, which is there is an interconnection between altered minerals and organic matter too. And this
Mhm.
becomes established after the first 40, 50 years since the first exposure of those sediments, which used to be underneath the glacier. Now, of
Wow.
course, it all depends also on, the grain size, for example. The finer they are, the faster is the soil formation. On a
Mm.
boulder is much harder, for example. But taking away like some details, in general, we can say that soil formation is very fast when the sediment is freshly exposed.
Hmm.
On a Swiss glacier I did study for my PhD thesis, some first tiny plants and early soil shrubs could already form within these 40, 50 years of time span.
Hmm.
And in a way, life finds a way with a very quick pace, geologically speaking, of course. But as you know, Bishwa, geologists
Yeah.
are funny scientists, as their watch is slower than, say, a biologist,
Why?
because we have geological timescale that takes us up to billions. So
Oh,
for
I
us, a
see.
geological process that has a rock that, for example, the Alps are considered a fairly recent
Mm.
a fairly recent mountain range,
Mm.
and it's just a few tens of millions of years old.
Right. Wow. Um. So you mentioned about the soil formation. So how significant is the role of weathering in newly exposed glacial areas, and can this lead to new ecosystem or new agricultural opportunities for farmer? What do you think?
That's $1 million question, really. Ice-free areas mean areas with more potential for forests, shrubs, and other uses.
Hmm.
In the mining industry, but also mineral collecting, ice-free surfaces mean a virgin, so to speak, area to explore.
Right.
With time and an appropriate soil evolution, one could possibly exploit those areas for human-friendly uses, pasture, and I'm talking way down the timeline, obviously, agricultural uses, why not?
Hmm.
However, there are an
Yeah.
enormous number of caveats. If glaciers melt, also water availability downstream will be progressively limited. As my
Mm.
kid says, this is part of the water cycle then. So this
Mm.
becomes a burden. If your
Yeah.
original water source, glacier in this case, is no longer available, you might want to build water reservoirs while relying on rainfall. However,
Yeah.
the weather might be dry, or the area might
Mhm.
not be feasible to build a reservoir.
Yeah.
Just to mention a few drawbacks, let's not forget also at this point, Bishop, that quite often glaciers are in steep positions, quite hard either to build anything on its bedrock or just to make a land use fit for human purposes, left alone the fact that in steep
Right.
terrains, even forests can't properly develop.
Wow.
Therefore, in lots of cases, ice-free areas simply become an area that once hosted some ice, and now, well, they no longer do. So long
Mm.
story short, a loss on multiple levels, but also numerous complications come into the game.
Right.
Now, visual, another important point is that mountain and cold areas are fragile environments, and they are
Mhm.
particularly sensible to climate change.
Yeah.
We do not need 10 degrees Celsius to upset the known balance. Half degree
Really?
is sometimes enough to trigger a chain reaction.
Wow.
And this is what we are experiencing nowadays. Allow me to provide a brief example that I experienced
Please,
myself.
please. Yeah.
In 2012, I worked on the Wind River Range in Wyoming, USA. There,
Mm-hmm.
there is a double tree line, a bottom one marking the limit between the dry shrubland and the forest, and an
Right.
upper one marking the limit between said forest and no trees line, way up to the Rockies Divide.
Mm-hmm.
Climate change is pushing the forest towards higher, fresher altitudes for the sake of the tree survival, right?
Right.
Now, factor in two things: the presence of a mountain pine beetle, which is infestating and decimating the pines of the Rockies, and the
Mm-hmm.
raging wildfires that ravage said ranges every year.
Yeah.
The forest is trying hard to move uphill, but it is having a hard time. At the same time, along the divide, the topography becomes significantly steeper, as mentioned before.
Yeah.
Therefore, this is a really hard time for forests and related ecosystems to adapt.
I see. It's a very interesting fact, actually. I'm sure my audience will love these episodes because they will get some different ideas what I usually publish in my podcast. So thank you so much, Chris, for explaining
Sure.
all the things. So I was talking informally with you the other day when we were setting up things and about the podcast and everything. So you're talking about like honeybees and different particulate matters, right? So I would like to learn more about it. So moving to your work with honeybees, how did you come to use bees in detecting particulate matter emissions? Because you told me that it was part of your one of projects, right? If I'm not wrong.
That's right. That's right.
Yeah.
Yes. That was a side project.
Oh,
And
okay.
to answer your question on how I came up with that idea, I can tell you that we came up with that idea, me and a couple of friends, literally over dinner.
Right.
I
Okay.
was talking to a friend, a renowned Italian entomologist, in the middle of a hot Italian summer. We were
Uh-huh.
surrounded by mosquitoes, and we thought, wouldn't it be cool to be surrounded by less annoying and more useful insects? My friend rightfully pointed out that honeybees would be nice, as they are reliable environmental sentinels and indicators. Within a
Okay.
short time, our thought went straight to observing the body of the honeybees to see what we could find, geologically
Mm,
speaking. We quickly found out that lots of things could be found, and quite often, some
really?
concerning stuff too. Oh, yes.
Wow. So what kind of particular matters can be able to detect, and how does this inform us about environmental health and so on?
We have to start considering the fact that honeybees do not discriminate what particles collect. They just fly for their own purposes, such as collecting nectar and water, and alongside specific parts of the body, they involuntarily collect whatever is in the air, mostly
Okay.
particulate matter-sized material, which
Mm-hmm.
means submillimetric particles, so really the teeny tiny fractions that would not interfere with the flight of the insect.
Right.
Now, studying the individual particles that the honeybees unknowingly connect allows us to understand the origin of those particles, which quite often can be pollutants.
I
A recent
see.
study showed that in a big city like Milan, in Italy, the
Mm.
honeybees were carrying particulate matter with barium, a heavy element quite often used in
Wow.
industry. Now, scientists link those particles to car brake pads, which are used in cars with both electric and traditional combustion engine.
Yeah.
And given the fact that particulate matter is linked to a number of pulmonary, cardiocirculatory diseases, and cases of morbidity even, such
Mm-hmm.
findings have the potential to change the reading of the narrative around green transition. Try to
Right.
think about the fact, Bishwa, that we can potentially prove in that case that while we look at thermal engines as the absolute evil, perhaps we're ignoring the entirety of the picture. So this gives really food for thought.
Wow. It's very interesting. So you mean that so honeybee anyhow they collect all the like dust chemicals in the environment, and you can detect this kind of bad chemicals or whatever they're collecting, and you can predict what's going on in the environment, right?
That's right. It's a picture.
Okay.
We can photograph what the honeybee has collected, and we can do that just by observing specific portions of the body of the honeybees, and we can
Okay.
go and pinpoint each individual point, understand which point was coming from where. So we can understand the emitting source, we can understand what is the pollution, the source of the pollution of these very
Okay.
particles.
Right. So as you mentioned that you can literally see, so how do you see? It's a very teeny tiny, like could be chemicals particles. So what do you use to see that chemicals of, like, can you tell me
In
how
this
did you?
study, we did
Yeah.
use electron microscopy. So it's
Okay.
a technique that basically allows us to see really tiny fractions. We're talking about a few micrometers, so we are really sub-millimetric fractions. And this
Right.
is very important to understand not only the origin as chemistry, but also the shape, because some
Hmm.
of those fractions, for example, can be like sharp as blades. Some
Yeah.
other fractions can be rounded, and they might give us a specific insights as to, for example, the origin.
Yeah.
And I can also give you some examples down the line later on.
Okay. Good. Thank you. So Can you share some insights or findings from your research on honeybees and how you monitor environmental changes using honeybees? And it could be very interesting for many people who are listening today this podcast.
So I can showcase you and to our audience
Yeah.
our findings from the study that started in 2013. Back in the
Hmm.
days, we sampled honeybees in southwestern Sardinia, in Italy, at a
Okay.
hive a few kilometers from an abandoned mining area. Given the
Mm.
premises, of course, we were expecting to find some mining minerals and some soil particles. Nothing more than that. Therefore, it was just a pilot study, as you can imagine.
Yeah.
However, we found more than we were expecting. For instance, we detected some spherical particles whose origin is usually linked to high temperature smelters. Now, the only thing even remotely close to that in the area was a chimney, approximately 20 kilometers distant. A
Hmm.
honeybee will traditionally try to cover 1/4 of that distance, so just a few kilometers.
Hmm.
However, if one accounts for winds blowing from the chimney's direction,
Yeah.
then this could have well carried the particulate matter closer to the honeybees. What
Mm.
is scary in that story is that local environmental regulations stop sheep from grazing at a radius of 5 kilometers around said chimney. However,
Wow.
the fact that we found compatible particles at 20 kilometers from the chimney shows that maybe the true impact and presence of those particles has been.
Yes.
Therefore, honeybees
Yeah.
tell us a story. They're our allies, and their help is priceless also in this context. And if I may,
Mm.
this is a help that is both largely underestimated and most unrewarded.
Right. Many people they're exploring Mars, right? So I'm sure like there are a lot of minerals into Mars. So my next question will lead that so how the study of minerals and then other matters on Mars help understand the planet's surface and history? Is there any correlations? Let's say you are doing research in Mars, and then how it gonna help for our planets? Do you
That's a
have?
good question. This is one
Okay.
of the questions that recurs all the time as to why we do it.
Yeah.
Let's start saying that Mars is distant approximately 140 million miles away from Earth. So while this might
Yes.
sound like an enormous distance, technically and on a cosmic scale, Mars is our neighbor, and
Yeah.
lots of handy intel can come from the neighbors.
Mm-hmm. Yeah.
Also, remember that minerals are stable at very specific conditions, as we mentioned before.
Yes. Yes.
Now, with a planet that has an incredibly thin, practically non existent atmosphere, no visible
Mm.
volcanic and water activity, practically we have no alteration going on right now. We can see from
Mm.
the combination of both satellite pictures and analysis of the minerals and chemistry what
Yeah.
were the environments that Mars could host.
Mm.
This is why such huge budgets are spent on those planetary missions. So the key questions are: is there life on Mars, and was there in the past? Did Mars have lakes, rivers, glaciers, volcanoes?
Yeah.
Now, the latter has been answered these years thanks to a thorough and wide use of what we call boots on the ground and eyes in the sky, which means rovers lurking on the surface and
Yeah.
satellites orbiting above the red planet.
Mm.
But also because of the study of minerals, they tell us so much. And the fun thing is, dirt is key. The ones we
Yeah.
often see as mud, when they're wet. And the
Yeah.
sulfates, the ones that are linked to extreme forms of life, are
Hmm.
essential to decode the processes that took place on Mars.
I see. Is there any similarities and differences comparing Earth's geological process to those on Mars?
There are. On Earth, we find several of what are called analog environments. The
Mm.
volcanic fields of Ireland, Hawaii, and Ertaale, the
Yeah.
oceanic floor alteration in Oman, the biological
Mm.
derived stromatolites in Australia, the overly acidic rocks of Rio Tinto in Spain. All these places are well studied candidates for what could potentially be environments observed on Mars. By
Right.
studying closely what's on Earth, we can infer and make solid assumptions, or well educated guesses, if you allow me the expression, on
Hmm.
what to expect on the red planet. So, Mars in the past might have not been too terribly different from Earth when it comes to geological processes. And last but not least, the current approach is much more feasible to pursue compared to sending manned missions with chisel and hammer, for now at least.
Then, how can the study of minerals contribute to the search for life or past life on Mars? Is there anything you know about it?
Well, if minerals reflect specific environmental conditions, then the next logical connection is if there is life
Yeah.
in this condition on Earth, there might have been some form of life on Mars as well. Is that an
Hmm.
oversimplification, though? I don't think so. It's rather logics and the rigorous application of scientific methods, aka based on fact and evidences.
Okay, we talked a lot of about rocks, minerals, and all those things. So I want to talk about a bit future and broader implications of minerals, rocks, and the environment perspective. So considering all those angles, what do you see as the most pressing geological challenges or opportunities facing our planet today and probably for the future? So what's your opinion?
We end up in a more philosophical branch. I like that. Humans have the terrible tendency to always crave for more, modifying the environment around them. There is no search
Definitely.
for balance, for equilibrium. Think
Yeah.
of what geologists call Anthropocene, an era that is ruled by humans modifying the environment as a function of their needs. We're not
Mm,
even mindful with our own species. We literally kill each other, either to
true.
conquer or to
True.
impose an idea we believe in is right. This requires correction, not tomorrow, rather yesterday. That said, in my opinion, humans need to find ways to deal with pollution,
Yeah.
airborne, soil, and especially water,
Yeah.
because all of them are not infinite. On the contrary, they are limited sources and
Mm,
resources and become scarcer by the hour. We need to find better ways to use what we have. So, why do I mention pollution as a geological challenge, Vishwa?
yeah.
Well, geology can provide the materials and most of the answers. Most materials that
Mm,
are employed are derived from rocks, treated to different degrees and extents, of course.
right.
Science
Yeah.
has proven that we can use those materials to improve the living quality of humans, and not only. Dealing with pollution also means to face another hot topic, climate change.
Yes.
We are in
Yeah.
dire need of a paradigm shift when it comes to approach issues. My personal
Definitely.
recipe: fewer
Hmm.
politicians, more scientists in power. And when you ask me, ideally more geologists in the decision making panels.
Yeah, I agree. I agree with you. Definitely, we need more expert on that directions. Basically, they can take better policy and they can implement in a better way because they have like all expertise. So yeah,
Exactly.
I completely agree with you. So as you mentioned about for action, actually, how can the public engagement more effectively with geology and environmental conservation efforts? So how we can do it actually? Do you have any suggestion as a scientist? Can you tell me about it? Yeah.
Scientist is the key of what I'm going to answer to you. Because what I'm
Yeah.
going to say is not strictly related to geology, but rather applicable to science entirely. There
Hmm.
is a popular saying, ignorance is
Yeah.
bliss. And I believe that this is not applicable in science.
Hmm.
We need to make the world understand that science is cool practically and can literally save lives. How?
All
By
right.
making the world know how science, which is traditionally seen as a nerdy, boring, and elitist thing, can solve
Yeah.
real problems. In my
Hmm.
opinion, science outreaching is the way to go. In the last
Yeah.
years, I have seen a significant amount of science communicators emerging, a real surge. While not all of them are successful, there are some that are more engaging than others. Myself, I'm quite fond of a couple of them, one of which is Italian, and I have learned tons of stuff from them.
I
So, in an
see.
infodemic world, there is a growing thirst for reliable information and a dire need for culture. So, let's start with
Right.
science, ideally in a light, pleasant, engaging format. Long story
Yeah.
short, we need more science based podcasts like yours, Vishwa, and
Oh,
fewer
thank you.
reality shows.
Yeah. Yeah, definitely. We need more knowledge-based society. So this is my idea also to run this podcast. Like, at least if I can do like a big contribution to educate society, inviting all the experts like you. So that would be my really contribution to the society if people understand the facts, numbers, and science. So that's the idea of Cypod Chat. Looking forward to all the actions and the things. What are the some emerging technology or research areas in geology that excite you the most currently?
Sometimes, Vishwa, I think we rush too much. We do not value what we have at hand. I firmly
Right.
believe that we
Yeah.
should investigate the implementation and refining of lots of the existing tech. For instance,
Mm.
imagine whether we could semi-automate the quantification and qualification of particulate matter detection on the bodies of honeybees while they fly. We could understand what they are polluted
Oh,
with, and without capturing them, right?
exactly.
We dream of such solutions quite often, to be fair. And as
Yeah.
per the future challenges, we got three major challenges ahead: oceans,
Like.
pollution, and space. For
Hmm.
the first and the third, so ocean and space, we need to explore more. Absolutely. Push ourselves. As for
Right.
pollution, as I mentioned before, we need to be able to consume better through recycling, depuration, and reuse. We must
Right.
understand that materials can and must have several lives. Geological
Hmm.
materials, processes, and related tech can help change the world.
Nice. To be honest with you, I learned a lot of things today about the geology. I didn't have any idea. As you know, that my background is like all about the life science. So I never had a chance to learn about the geology. So today it was kind of my education about the geology, environment, rock, minerals, and so on. Thank you for all the explanations. To be honest, I really admired how you explained in a simple way. Before we wrap up, if you could give everyone one piece of advice or fact about the Earth's geology, what would it be?
Next time you look at a rock, whatever the rock, just think at
Yeah.
how old it is, possibly millions
Mm,
of years old, and what it has experienced. It certainly has a cool story to tell. The
yeah.
trick is to learn how to understand it.
Yeah. Okay. Cool. Thank you. Thank you, Chris, for this insightful conversation. To our listener, thank you for joining me on Cypod Chat. We talk science and let's know science together. Until next time, stay curious, stay inspired, and stay tuned for more exciting conversation right here on your favorite Cypod Chat. Take care. Bye bye. Thank you, Chris.
And
Oh, yes.
I
Perfect.
should say I rather speak science than politics sounds a bit harsh, like towards,
Yeah.
okay.
Okay.